Hey physics friends, and welcome to 2.6, which I am entitling Using Velocity Equals Displacement Divided by Time. We're gonna learn how to use this equation to our advantage in a lot of different scenarios. We're gonna start out very not complicated, and we're gonna get more and more complicated as we go. How much time does it take to travel? You and a friend are both driving, you want to go on a motorcycle trip, and what's the average speed, and so on. So we're going to do 4 example problems today using this equation. And before I do that, I've got a couple of videos I wanted to show you. Video number 1, talking about speed. This is the same racetrack. And these are on the right-hand side are F1 cars. And on the left-hand side are just regular GT cars. And it's just incredible the difference between them. I mean, you can see it right now when it comes to speed. You're like, oh, you think a Porsche or you think a Ferrari is fast. But then you have an F1 car come by, and they're basically an upside-down airplane. I mean, they can go twice the speed that these other can. There's another video I wanted to show you, and this harkens back to one of the first videos I showed you, and I don't know if it made sense to you when you saw it or when you did that motion diagram, but that motion diagram, believe it or not, showed you something very interesting. That ramp that you saw in the video, if you didn't pick it up in that motion diagram, that ramp is moving. The guy on the bicycle is not moving. The guy on the bicycle stands still, and then the ramp comes and drives right underneath him, kind of like a golf ball. If you were to take a golf ball and you hit it with a golf club and it goes straight up and comes straight back down, that's what it was. So I want you to go back and take a look at that picture one more time if you haven't, if you didn't notice that or nobody said anything or you didn't catch it in the discussion. But here's the real video I wanted to bring you to, right here. I forget her name. This poor young woman. But let's watch. Stephanie.
Going 80 miles per hour. How long will it take you to go 80 miles?
I don't know. Why do you keep asking me?
What is it?
I don't know. I said 10 minutes and you said no. And then I said 80 minutes and you said no. And then I said 8 minutes and you said no.
80 miles per hour. How long will it take you to go 80 miles?
What? Okay, if you're going 80 miles per hour, how long will it take you to go 80 miles?
Yeah.
I don't understand. Hold on, can't we put up to this? Okay. 80, so do I like divide something?
No.
80 miles per hour. How long does it take you to go 80 miles?
Yes.
I don't know, dude. What is it?
If you're going 80 miles per hour, how long will it take you to go 80 miles?
Dude, I don't know.
If you're going 80 miles
per hour.
No, listen. If you're going 80 miles per hour, how long will it take you to go 80 miles?
Per hour?
Mm-hmm.
I don't know.
What?
I don't get it.
80 miles per hour. Okay? So you're 80 miles per hour.
Okay.
So an hour, 80 miles.
Okay.
So how long will it take you to go 80 miles?
An hour.
Yes.
An hour.
Yes.
It'll take you an hour.
Yeah. Not 80 minutes, not 8 minutes, not 10 minutes.
Poor Stephanie. If she had only taken physics class back when she was in high school, she would have been saved that terrible ordeal. You know, if your velocity is 80 miles per hour, how long will it take you, because you don't know the time, to go 80 miles? solve that for the letter T. It's obviously 1, but that's what we're going to do today with this very first question. This first one's a little bit more complicated than poor Stephanie's. But how much time does one travel if you're going 5.8 meters per second for a distance of 59.2 meters? So I'm just going to substitute in my velocity is 5.8. My displacement is 59.2. And now I can solve this for time. Now, I specifically set this problem up because I can fool probably 30%, maybe less, maybe 15% of physics students with this question right here. Because what your average physics, that 30%, 15% is going to do, they're going to take 59 divided by 5.8, and that is not correct. You got to bring the t over, so you get 5.8 t equals 59.2, and then t equals 59.2 divided by 5.8. And then when you divide those things, you're going to get 10.2. But you're going to have to use significant figures. So this problem, everything's got, I'm limited by the 5.8, so I got to go 10. And I can't forget my units. And that time, let's see, this is in meters and seconds, so this is going to be seconds. The time is 10 seconds, but bummer, I got to use significant figures, so I got to write 1.0 times 10 to the 2 seconds. Let's go on to the next one. A little bit more complex. You and a friend both drive 50 miles. You average 25 miles. Your friend averages 22 miles. How long do you have to wait for your friend? Because you're going to get there first. You're going faster. How much longer do you wait? So let's try it. I'm going to use my equation. Velocity is equal to displacement divided by time. Me. I go 25. So it's 25 equals the displacement, which is 50, over t. So this one's a pretty straightforward one to solve. 50 divided by what equals 25? 2. Takes me 2 hours. My friend is going 22. So I solve that for t. 50 divided by 22 turns out to be 2.3. So friend is 2.3. So how long do I wait? I wait 0.3 hours. So I got to change that. The problem says I want to do it in minutes. So I'm going to go 0.3 hours and change hours into minutes using dimensional analysis. So 1 hour is equal to 60 minutes. And this has as many significant figures as you need because there is 60.000. You're never limited to significant figure-wise by a dimensional analysis problem. So 60 times 0.3 is going to be 18. Give that to one significant figure because that's where I'm at. It's 18 minutes. But because of significant figures, 20 minutes. Like that. Let's get a little bit more complicated. You go on a motorcycle trip. You cover the first half of the distance at a speed of 60, and you do the second half at 30, and what's your average? Let me tell you something. The average is not going to be 45. It is not going to be that. And you might think to yourself, Mr. Hare, but 60 plus 30 divided by 2, that's how we find averages. But that does not hold in the average speed world because the average speed is your total displacement divided by your total time. So here's what we're going to do, and I'm going to show you that the answer is not equal to 45. We're going to make up a distance. It's this trip. So here's home. Here's my destination. I'm going to make my trip 120 kilometers. So this distance right here, I'm going to make this distance 120 kilometers. You might be saying, why'd you make it 120 kilometers? And I'm going to tell you this. It's a magic number. And I drew a rabbit in the hat because you know why that rabbit is smiling? Because he likes physics. I made up the number 120 because it says when I do the first half. So that means the first half of this is 60 kilometers. It makes the math really easy. And if you go 60 kilometers at 60 kilometers per hour, how long did it take you? Don't be like poor Stephanie here. You're going 60 kilometers per hour at a distance of 60. How much time did it take? It took you 1 hour. Right? So it took you 1 hour for the first half of the distance. Now you did 30 kilometers per hour. So on this second part, you did 30 kilometers per hour. So, using that equation, my velocity is 30, my distance is 60, my time, the time it took me here is 2 hours. So, what is my average speed? Your average speed is your total displacement, 120 kilometers, divided by your total time. Your total time is 3 hours. What's 120 divided by 3? It's not 45. Right? Huge physics lesson. If it asks for the average speed, you can't just average the speeds that were given. You got to take the total displacement and you got to divide by the total time. Now this answer right here, got to use significant figures always. Don't think I wasn't going to forget that. 4.0 times 10 to the 2 kph. Final answer. It's not 45. Please don't fall into that trap. Number 4, last one. I'm just going to take that exact same problem that we did last time, and I'm going to spin it on its head just a little bit. So I'm planning a bicycle trip, and I want to average 60. I'm not looking for the average. I already know I want my final end-all average to be 60 kilometers per hour. You cover the first half of the trip distance at 40. How fast do you have to go to meet your end goal? I'm going to tell you right now, kids, it is not 80. Because you're like, oh, this is 20 below, so I just go 20 above it, and it's 80. It will not be 80. The answer is not going to be 80. Let's figure it out. So, again, you need to be a little bit tricky. Why is he smiling? You guessed it. He likes physics. So, let's pick a distance. That's the tricky part. It turns out you can pick any distance that you want, but picking a good distance is going to make the math so much nicer. And this answer will be just flow freely. I mean, you could pick 100, but I'm telling you right now, 100 doesn't work for this because you want to average 60. So, right, the velocity that we want is equal to 60. And then the first half is 40. So maybe there's a number that where we go the first half of it, that works with 40, but when we go the whole thing, That also works with 60. So I'm just going to go in my brain. 60. If I made the distance 60, that's not going to work. 120 for the whole distance, that makes that doesn't work with 40. I'm going to go 240. Let's try that. 240 kilometers. That works with 60. And then half of 240 is 120. That's going to work with 40. So there's my magic number. I pick a nice distance. Again, you could pick 1 kilometer and your math is going to end up being the exact same as mine. But when I pick a little bit of clever numbers to help me work with this problem, it makes it much, much easier. So, the velocity that I want to have 60 kilometers per hour. My displacement is 240. So how much time does it need to take? It has to take 4 hours. 240 divided by 60. The time it has to take total is going to be 4 hours. That's important. This entire trip has to take 4 hours. And if I can do the entire trip in 4 hours, life is good. I've averaged 60 kilometers per hour. So, how fast? Let's talk about my first half. Velocity first half equals the displacement first half divided by the time first half. So my velocity of my first half is 40. The displacement of my first half is 120. And the time. See how these nice numbers are working out in our favor? The time it took me is 3 hours. So I spent 3 hours on the first half. I need the total to be 4 hours. So guess how much time I have to spend over here? I have to spend 1 hour. Boy, this math is sure nice. So how fast do I have to go on the second half? Velocity second half is equal to the distance second half divided by the time second half. The distance for the second half is 120. The time for the second half is 1 hour. So I have to go 120 kilometers per hour. Not 80. Total displacement divided by the total time. So, these problems, which on their surface seem very simple, and simple is a very dirty word, always think about when it's asking for the average speed, it's the total displacement divided by the total time.